Right. Let's start the class. Let me share the screen. Okay. So today we are going to learn about Le-Chatelier's principle, right? Um, we have learned something about Le-Chatelier's principle in the previous class about the concentration changes. Today we are going to learn about the what will happen to to an equilibrium which is already in equilibrium when a pressure change, when volume change, when temperature change, and yeah, those are the things that we are going to learn today. Okay, so write the topic. Change of pressure and volume. Okay, so change of pressure. Change of pressure means this is mainly pressure is impacted by gases, not the liquids, not the solids. So basically, when pressure changes, most affected equilibrium will be gaseous equilibriums, not the solid equilibriums, not the liquid equilibriums, but the uh, uh, gaseous equilibriums. Right now, let's say we have a gaseous equilibrium, something like this: 2N2 gas plus H2 gas. I'm just giving an example, right? 2N3 gas. So let's say this is an equilibrium. So we know in this side, 4 moles of gaseous moles are there. Here, 2 moles of gaseous moles are there. 4 and 2. I have taken this one just for the explanation purpose, right? So let's say now this is in a kind of a closed container. Equilibrium means we have N2 gas, we have H2 gas, and we have NH3 gas altogether. Right? Let's say we have like V volume, and it is in P1 temperature, P1 pressure and T temperature. Let's say we change the parameters only in pressure into P2, where P1 is greater than P2. Or let's say other way around for the moment. P2 is greater than P1. Okay. So now the system pressure has been increased. Pressure increase means without changing the volume. So for the total system and for the total number of moles inside the system, the pressure has been increased. We don't know how the pressure is increased. Let's say it is increased, right? By any means. So let's go to the basic that PV equals nRT. So in here, according to Le-Chatelier's principle, we know system will try to do whatever the opposite that external environment does. So that is what system do. System will try to negotiate, which system will try to negate, compensate whatever the external environment does. So here, pressure increases means system will try to decrease the pressure. System will try to decrease the pressure means, according to our basic, let's try to understand how the system is going to reduce the pressure. Here the volume is a constant. Volume is not changing. Let's for the moment, right? R is always a constant. Let's say T is also a constant because in equilibriums always pressure, so temperature is also considered as a constant. So we can directly say pressure directly proportional to N. So system will try to decrease the pressure by changing number of moles. Now, if you look at the equilibrium again, in this equilibrium, the product side has 2 moles and reactant side has 4 moles. So which means if the system try to move towards the products, it can reduce the number of moles, total number of moles I'm talking about. It can reduce the pressure, it can reduce the number of moles, and also it can reduce the pressure as well. So whenever a system, equilibrium system increases its pressure, it will try to decrease the pressure. How to decrease the pressure? While keeping R, T, and V as constants by changing number of moles. So therefore, always it will move towards the lower number of moles side. It can be either products, it can be either reactants. You have to check it for a certain equilibrium. So go for it, check it. When the pressure is increased, system will try to move more towards the direction where you have lesser number of moles. If the lesser number of moles is in the product side, system will encourage the forward reaction. If the lesser number of moles in the reactant side, system will encourage the backward reaction because more reactants has to be produced, right? So you are talking about the total number of moles. Yes, that's true. Industry is producing if the forward reaction is encouraged, but number of moles will be reduced. That's how it try to reduce the pressure. Higher the number of moles, according to this equation, higher the number of moles, higher the pressure. That's why. Okay, so this is the pressure impact to the system. Pressure impact to an equilibrium system. When the pressure increases, system move towards the lower number of side. When pressure decreases, system will try to increase the pressure by increasing the number of moles. So therefore, it will move towards the higher number of moles direction. So this is the pressure impact to a equilibrium and how equilibrium behaves according to the Le-Chatelie's principle.